question goes on to talk about adding another resistor X in parallel with the second resistor 6, and we're told that another resistor is connected in parallel with the 6 ohm resistor. When that is done, the current in the 2 ohm resistor becomes 2 amps. What is the value of this resistor X? All right. In order to calculate this resistor, then the first thing that we need to do is find out what is the voltage V1 across the 2 ohm resistor. So we say V1 is equal to I times R, where in this case I is equal to 2 amps and R is equal to 2, so that's equal to 4 volts. We now have 4 volts across this 2 ohm resistor, which means that the voltage V2 across here, V2 must be equal to 12, the total voltage, minus V1, which is the voltage across here, which is equal to 12 minus 4, which is equal to 8 volts. That means that we have 8 volts across this parallel network, 8 volts across the 6 ohm, 8 volts across X. So now what I can do is I can work out, and there's a couple of ways I can do this now, but I'm going to just take this 8 volts and 6 ohms and work out the current that flows in to the resistor here, which I'll call I1. So that means if V equals IR, then I have that 8, the voltage, is equal to I1 that I'm looking for times 6 ohms. So that means that I1 must be equal to 8 over 6. So the current, this I1 here, that current is equal to 8 over 6, or that's 1 2/3 going through there. So we have 1 2/3 going through here. If 2 amps comes down here and comes along here, that means that the current then that goes down here is equal to that's 1 1/3. Right? 8 over 6, 1 1/3. 1 2/6, 1 1/3. So that means that the current that's flowing down through here must be, if I call that I2, the current that flows through there, I2 then, is equal to 2 amps coming in minus 1 1/3, which is equal to 2/3. So we have 2/3 of an amp coming down through here, and now I can say for this resistor here on its own, that means that V equals IR, and this is the resistor X that I'm looking for now, so that means that 8 is equal to 2/3 times that resistance of X, which means that the resistance of X is equal to 8 divided by 2/3, which is equal to 12, which then gives us 12 ohms. So this is a 12 ohm resistor in this parallel network here, along with that 6 ohm resistor. Now, this is one of the more difficult questions that have been asked in terms of these resistors in networks, either series or parallel networks. And there are a few steps to getting that, and it's just following through the steps. So again, what I did first of all was I calculated using this what the voltage was across there. So V is equal to IR, so that's 2 times 2 to give me 4 volts across here. If I have 4 volts across here, then with 12 volts in total, that means I have 8 volts left across this parallel network. So that's 8 volts across the 6 ohms, 8 volts across the X. Then, using V equals IR, I can work out what current flows into the 6 ohm resistor. So that's 8, the voltage across it, divided by 6, the resistance, gives us the current, which is 1 1/3. With a current of 1 1/3 going through there, that leaves 2/3 to come down here, because 2 amps came through here, 1 1/3 there, 2/3 down through here. So I now have a voltage of 8 and a current of 2/3 going into X, which means that the resistance of this is equal to 8 divided by 2/3, which then is 12 ohms. So the answer here, X, is 12 ohms.